Hey everyone, welcome back to the channel. In today's video, we are going to take a deep dive into the custom sorting in C# using the LINQ. We'll explore different scenarios where you might need to sort your data beyond the usual ascending or descending order, and we'll see how to implement those in real projects. Let's start with something simple but common. Imagine you have a list of employees and you want to sort them by salary in descending order. So here we have a class for employee with some members. So we have name, department, salary, joining date, and performance rating as a member of employee class. Now let's initialize the employee list. To initialize the employee list, we can write var employees equal to new list of employee. And here we can initialize the employees. So let's say I'm adding a new employee whose name is Alice, department is IT, salary 85,000 million, joining date is, it's a type of a date time, so we are initializing a new object of a date time here. So new date time, and then 2018 as a year, March as a month, and 15th as a day. And then the performance rating. So our performance ratings varies from 1 to 5. So for this particular employee, we are giving a rating of 5. So this is how we have created our first employee. In the same manner, we can create the rest of the employees. So here is our rest of the employees. We are going to perform various operations on this list of employees, and after performing the operations, we wanted to show the list of employees to verify whether the operations has been successfully performed or not. So let's create a method to show all the employees. So here let's introduce a method. We'll call it as a show employees. It will take a list of employee and we'll call that parameter as a employees. And inside it, we will have a for each loop which will iterate through all the employees. And then we will display all the properties. So we'll start with the name, then department, salary, joining date to short day string, and then performance rating. So these are all the properties that we are going to display. Now let's call this method to verify how the employees are displayed. Now since this employee is a non-static, so we'll need a reference of it. So let's make it a static and realign the code. And now let's verify. So this is how our list looks like before performing any operations. In the first operation, we are going to sort the list of employees by salary in descending order. So let's write a code for it. Now let's break down the expression. So here we are having the list of employees. So it's a collection of employee object. And then we are using the method called as a order by descending. This method will sort the collection so the highest values come first. And then for each employee from the employee list, we are using the salary property as a sorting key. And once the collection is sorted, we are storing it into the variable called as a sorted. Now if you observe here, the order by descending method is returning the I ordered enumerable, and our show employees is taking the employees in the format of list employee. So if we pass this sorted to the show employee list, we'll get an compilation error because it's expecting to be list into the list employee format, but we are passing it in I ordered enumerable. So to fix this, we need to modify this parameter data type to I ordered enumerable of employee. Now let's execute the code and check the results. Now as we can see, now we are getting the results in the descending order of their salaries. So the first employee, Ethan, has a salary of 99,000, and the last employee, who is Fiona, is having the salary of 55,000. So all the salaries has been sorted into the descending order. In the next operation, let's sort the employees by the salary in descending order and then by joining date in the ascending order. That means if there are two employees with the same salaries, then first they will get sorted with respect to the descending order of their salaries and then by the joining date in the ascending order. So for that we will need one more entry which will have a similar salary with one of the employee. So I'm just copy pasting this Ethan employee. We'll call it as a Jack, who will be from the IT department, will have the same salary as Ethan, but his joining date is 2015 and Ethan's joining date is 2016. That means Jack is more senior than the Ethan. If we execute this code, we can observe that using the lost logic, we will get the Ethan first and then Jack, because in the list the Ethan has been specified before the Jack. But our requirement is that if the salary of two employees are same, then they should get sorted in the ascending order of their joining date. So for that, what we have to do is we'll modify the existing code. So here we have already sorted our employees with respect to the salary in the ascending order, and now we want to perform the multi-level sorting. That's a two-level sorting, and this time we are going to sort the employee with respect to the joining date. Now let's execute the code and see the results. Now we can clearly see that the Jack is listed before the Ethan because Jack is senior than Ethan. His joining year is 2015 and the Ethan's joining year is 2016. So this is how we can sort the collection in the multi-level using the LINQ. Next, let's say you need to sort employees by the department name first in the alphabetically manner. But within each department, the highest paid employees should come first. So again with LINQ, you can combine order by for the department and then by descending for the salary. So let's see how this can be done. So here, let's modify our LINQ query with order by, with the department first, and then with salary. Now let's run the code and see the output. So here you'll see all the finance related employees are ordered first, and also their salaries are in the descending order. Then we do have a HR employees. Again, their salaries are in the descending order, and then we do have the IT employees. So this is how we can sort department alphabetically and then salary in the descending order. Now sometimes your sorting needs can't be handled with just ascending or descending orders. For example, maybe you want to completely a custom rule, something based on the business specific condition. Here we can use the order by overload that takes a custom selector or even write an inline comparison function to handle those rules. See how we can do that. So here I am modifying the logic. So for all employees, we are ordering by department, which is equal to the IT. And here we are using the ternary operations. So if it's equal to the IT, then we are specifying 0, and if it is not, then it's specifying 1. That means all the employees with the IT would get listed first, and then the other employees will get listed. After that, we are sorting over the performance rating in the descending order. So let's say here for all employees, we are sorting them with the performance ratings, and after performance rating, then we will sort them with the name in the ascending order. So here we are making the use of custom selectors. It's a custom logic. Using it, we can sort all our employees. Now let's run the code and see. Now here you can see, as we have specified that we need all the IT employees first. So here we have all the IT employees. Then in the descending order, we have sorted those employees with the performance rating. So you will see that Alice is having the 85,000 salary and Jack is having the 99,000 salary. But here, since we are performing the sorting on the basis of performance ratings and then by the name, that's why we are getting the Alice first and then the Jack. So here how we can make use of the multiple conditions with a custom logic. Now here's the fun one. Let's sort by the length of the employee's name first, and if two names have the same length, then sort them alphabetically. This is perfect for scenarios where presentation or naming convention matters. We'll use the length property in our LINQ query and we'll combine them with the then by. So let's see how it works. So here, first like we are ordering by. So till now we were using the properties only, but now we are also using some inbuilt properties. So here we are making the use of length property, which is the part of the string class. And then we will sort them with the names. Now let's see the output. So here, since we are ordering by the name with its length, so you will see that the Bob, which is having only the 3 characters, is at the top, followed by the Ian. So now, since we are sorting them with the length of a name and then with the name in the alphabetically manner, that's why we have the Bob first and then Ian. And then we can observe that the length of the names is in the increasing order. So Bob, who's having the 3 characters, is at top. Then we have Jack, which is having the 4 characters. Then we have Alice, which is having the 5 characters. And then we do have the Charlie at the last, which is having these 7 characters in it. So this is how we can sort by length of an employee name and then sort them in the alphabetically manner with the name. Now, what if LINQ built-in methods aren't enough? That's where IComparer comes in. We can create a custom comparator or class, define our own comparison logic, and then plug that into the sorting method. This gives us the complete flexibility to implement even the most complex rules. Now let's see how this can be done. So at the top, we are implementing one more class. Let's call this class as a salary comparer. So we have a class, and now since this class is a comparer, so this will implement one interface called as a comparer. And since this interface will operate on the employee, now if you hover this IComparer, you will see that it is not implementing the interface member, which is called as a IComparer. So let's fix it and implement the interface. So this is how this method is implemented. Now let's add our own custom logic. Now let's say here, since this is our own comparer, we want to sort the employees depending on the salary in the descending order that we have already performed before. But along with that, also we want to sort the employees in the performance rating in the descending order. That means if there are 2 employees with the same salary, then those will get sorted with the performance rating in the descending order. So here we will need a 2 logic. One is the primary logic, which will be sorting the employees in the salary in the descending order, and then we will need a secondary logic which will sort the employees on the basis of the performance rating, again in the descending order. Now let's implement the logic for the primary. So let's say here we declare a variable. We'll call the variable as a salary compare, and then y dot salary dot compare to is dot x dot salary. Then if salary compare is not equal to 0, then we will return salary compare. So here we are comparing the salary of y with the x, and then if it is not equal to 0, then we are returning the object of the salary compare. And here is the second logic. So return y dot performance rating compared to x dot performance rating. So we need to pass 2 employees to this, and we are comparing first whether the salary is equal or not. If salary is not equal, that means for the employee whose salary is greater, then that will get returned. Else, if the salary is equal, then we will perform a secondary sorting logic which will sort the employees on the basis of the performance rating. So this is how we have created a class for the salary comparer, which is implementing the IComparer. Now how to utilize this class? To utilize this, simply what we have to do is we will say order by. Until now we were using the existing properties of the LINQ, but now instead of the existing properties we will say that I want to use the salary comparer class that we have created. And that's all. So now let's run the program and see how it works. So here we can see the salaries as well as the performance. But here most of the employees is having the different salaries except the Ethan and Jack, but for them the ratings are same. So both is having the 5 rating. So let's modify a little bit. Now instead of giving the rating of 5 to Ethan, let's give a rating of 4. So we have modified the Ethan and we have degraded its rating to 4. Now let's check the output. And now here we can observe that we have the entry for the Jack at the first at the top because it's having the 99,000 salary plus its rating is 5. And then we do have a Ethan which is having the same salary but whose rating is 4. Now let's swap the ratings and check this again. Now we can see that Ethan is listed first now because we have modified its rating to 5 and we have degraded the rating of Jack to 4. So if there are no inbuilt methods available from the LINQ, then you can always use your own custom logic. You can implement your own salary comparer or like any kind of comparer and have your own custom logic to do the comparisons. Now let's look to another interesting case. Let's sort by the quarter in which the employee joined. We can extract the month from the joining date, map it to a quarter, and then sort accordingly. It's a great example of how LINQ lets you transform and sort your data in one go. To do so, let's remove this and let's say that I want to order by first with the joining date, and then we will be using its month property, and since it would be the integer division, so we are removing the 1 from it, and then since we want to divide them into the quarter, so we are dividing it by 3. So this is how we can make use of some extra properties to have our own custom sorting. So now once we have sorted or once we have separated all the employees on the basis of the joining date in the quarters, then let's sort by the joining date. So in the first statement we have divided the employees in the quarters. So here we will get the quarter number, and then we are actually dividing or sorting those quarter numbers. The reason of subtracting -1 is because we are having this integer division, so the first, second, third, this will go into the first quarter. Now if we do 3 divided by 3, we will get a 1. So just to avoid that situation, we are subtracting it with -1. Now let's see the output and confirm our logic. Now here you will see that first we have all the employees from the March and January. Then we do have employees from May, June and April. Then we have some employees from July and forward. And at the end we have the employees which belongs from the last quarter. So this is how we can sort our employees on the basis of the quarters in which they have joined. Now finally, we will tackle a slightly tricky requirement. Let's sort by department, but not alphabetically. Instead, we have a custom department order defined by the business. We can handle this by creating a dictionary or list that defines the order and then sort employees based on the index of their department in that list. Let's see how it can be done. So first, let's define the department order. So here we are making the list of the strings. Let's have finance, IT, and HR in the list, and then let sort them by the department order that we have specified at line number 54. And we want to have them in the same sequence. So we'll be using the index of property for the E dot department. And then we will sort them in descending order of the salary. So here we are making the use of the list that we have defined. We are using the index of property so that we will have our results in the same sequence as we have specified inside the department order. And once we have that, then we will sort it by the descending order of the salary. Now let's see its output. So here, as specified above, we are having the results from the finance, IT, and HR in the same sequence how we have defined at the line number 54. So first we have the results from the finance department, then IT department, and then HR department. Along with that, we are also sorting them in the descending order of the salary. So this is how we can implement a slightly tricky requirements using the custom logic and by using some other properties of some other classes. And that's it. We covered a wide range of custom sorting techniques in C# using LINQ. From simple to multi-level sorting and from multi-level sorting to the complex one. We have also implemented a fully custom rules. If you found this video helpful, hit that like button, subscribe for more C# tutorials, and drop a comment below with your favorite LINQ tricks. Thank you for watching, and I'll see you in the next one.